All right, class, in today's lesson, we're going to answer the question, how can we divide with matrices? Now, if you recall from last lesson, we learned we actually can't divide. What we do is we use the inverse, and we spent all last week kind of talking about the determinant, if we determine if we have an inverse, and actually finding an inverse. Now we're going to talk about how do we divide using this inverse. So, we looked at 2x equals 8 last week. And when I look at 2x equals 8 and I tell you, hey, you can't divide by 2 on both sides because that's our instinct. But what if I said we couldn't do that? So what we ended up doing is multiplying 2 by its multiplicative inverse. And to get rid of 2, or not get rid of it, but make it equal 1, we're going to actually multiply by 1/2 on both sides to keep it nice and even. And when I do that, two things. First thing, I know that this 1/2 times this 2 will cancel the 2's out, leaving me with 1, which is its identity. All right, so instead of dividing by 2, we multiply by 1/2. Gets the same math going on that we need to go on. But here, right here, what I just wrote there separates matrix math from all of the math. Matrix multiplication is not commutative. And what I mean by that is if I take A times B and switch their order, I will not always end up with the same thing. So 8 times 1/2 and 1/2 times 8 are just the same things switched. But if you notice, these cancel, I get x equals 8 times 1/2, 8 times 1 is 8, divided by 2 is 4. That's one way to look at it. Half of 8 is still 4. That doesn't always happen with matrices. So we cannot actually do it this way. What we need to do is specify the order. AB does not equal BA. AB equals AB. So we need the same order. So let me walk you through an example to kind of explain what I actually mean with this. I have this matrix here, nice 2 by 2, times a variable. Now the first thing I notice about this variable is it is capitalized. A capitalized variable means it is a matrix in and of itself. So this matrix right here, I can even tell you the size of it in a minute, is going to be multiplied by this matrix, and they're going to result in a 2 by 2. So if I have a 2 by 2, just going back to our other lesson, and I know I have a matrix here, so it's something by something, and I know my final answer is a 2 by 2. That means that these 2's have to match, so this is a 2, and this 2 is that guy, then this guy will be this 2. So I know that I am looking for a 2 by 2 matrix as my final answer. And that was just a little side note. Now, going back to this problem, we're going to call this matrix right here A. X is a matrix that we're trying to solve for. We know it's going to have 4 entries, 2 rows, 2 columns, and this is matrix B. So down here, I'm going to simplify it. I'm going to take the numbers away just so I can kind of talk to you guys about this. I am going to take matrix A times matrix X, and they are going to result in matrix B. In order to solve for matrix X, which is my unknown 2 by 2 matrix, I am going to multiply times A inverse up front. So I'm also going to have to multiply by it up front here. Order matters for matrices. So these are going to cancel out, and my matrix X is going to be A inverse B. So at this point, we're going to go right to the calculator. It's going to be great. So we're going to go to our Desmos matrix calculator. And I've kind of minimized mine a little bit so I can move around my screen. I'm going to identify matrix A. So I'm going to input a new matrix. It always starts with A. It's a 2 by 2. I'm going to type the entries in. -2, remember it doesn't use negative, it uses minus, which is so against calculators, but that's okay. 4, 8, and 7. Now I'm going to enter this and do a new matrix. It's also a 2 by 2. It's matrix B. Now, B is going to be 20, 22, -8, -3. I'm going to hit enter, and now I've defined the two matrices in my calculator. So now I am going to just hit A inverse B to actually find the answer. So A, there's A, it pops back up, yeah. Inverse, oh, that's good. Now, this tells me there is an inverse, which means I can divide, okay? And then I just hit B, and here's my beautiful answer. Ms. Frybush, it has lots of decimals. I understand it has decimals. Not everything is going to work out perfectly with these lovely numbers. I'm going to round this to the thousandth and write this on my paper. I'm very lucky. I already did that today. So I have my lovely answer here for this, that x equals these. Okay? Let's do another example. All right, so I have the second example, solve for x. So I'm going to come here, and I'm going to call this A. It's always AX equal B. Always AX equal B. All right, so now I'm going to put A in my calculator and B in my calculator, and I'm going to solve this by A inverse B. Always, always, always. Okay, so I'm going to go into my Desmos calculator, and I'm going to clear out. That just blanks everything out. Any information I typed in is gone. Start with a new matrix. This is a brand new A, brand new problem. Oh, there you go. So I'm going to put 4, -1, -3, 1. Over a little bit. And then for matrix B, new matrix, I've already defined A, so it switches to B automatically for me. I'm going to put 8, -5, -6, and 3. Enter. Now I'm going to do A inverse. Whew, good, there's an inverse, which means I can use it. Times B, and it gives me the final answer for this. So I know that what I multiply A by to get this answer is going to be this matrix here, 2, -2, 0, -3. Okay. So there is my final answer. All right, let's do another example. This last example, actually, I'm going to do two with you real quick because I want to point out something that's going to happen here. This next example I have is actually an extra step. So I'm taking matrix A here times my unknown, but then matrix B I have separated here. So if this was 2x plus 1 equals 5, I would have to minus 1 on both sides. So I'm going to subtract this matrix on both sides. And you guys should be experts at this now. This will cancel with this, and here I'm going to have to subtract each entry with their same location. So this first matrix with 3, 1, 2, -4 is fine. But over here, I'm going to have to do like a two-step process. I'm going to have to subtract this first. So 3 minus 5 is -2. 1 minus 1 is 0. 8 minus 0 is 8. And 4 matches up with 2. Subtracting them will give me 2. So now I know this is A, this is B, and I know X is going to equal A inverse B. So I'm going to plug these into my lovely calculator. I have to clear out first the information. New matrix, 2 by 2, 3, 1, 2, -4, say thank you, define that, and I'm going to do matrix B. New matrix add, -2, 0, 8, 2. Say, yep, that's B. And now A, oops, A, inverse, good, it exists, B. And there's my final answer for this guy here. And I actually already have it, but I took a screenshot of it. There I go for that lovely matrix. Now, I said it a couple times. Oh, yeah, A inverse exists. And in this next problem, A inverse doesn't exist. What I want you to do is pause on the video and try and move this guy over and see if you get it. While you're doing that on your own, I am going to actually just write down what it's going to be. 5, 2, 5, 2, x. And then 4 minus 2 is 2. 10 minus 6 is 4. -6 minus 4 is -10. And -4 minus 2 is -2. So something's going to happen with this one. What's going to end up happening is I'm going to come and I'm going to get my Desmos calculator. I forgot to minimize him, so let me get him. Remember, clear out the information that you have. And I'm going to put this in. A is a 2 by 2, 5, 2, 5, 2. And I'm going to say, yep, that's A. And then I'm going to put a second matrix in. And it's going to be 2, 4, -10, -2. And here's where the excitement is going to happen. I'm going to hit A inverse to start solving this problem, and this guy pops up. I could even hit B if I wanted to. What happened is you actually don't have an inverse for A. If you remember from last lesson, your determinant determines. My determinant is the difference of the diagonals. This diagonal matches this diagonal. So 5 times 2 minus 2 times 5 is going to get me 0. That can happen sometimes, that these cancel out. My determinant is 0. If I don't have an inverse, then I cannot actually solve a problem like this. This has no solution. So x equals no solution because I can't do it. Okay, I'm not going to do that on the 3 that I'm going to ask you to do now. So I have these 3 problems here. Number 1, I want you to notice that I've actually broken it down into a matrix. So we're still going to do number 1 the same way. Here is A, here is B, this is my matrix X. This is a 2 by 2 times a 2 by 1. I still want you to solve this A inverse B. So I want you to plug this in the calculator, this in the calculator, hit A inverse B. I want you to try these 3 problems. I'm actually going to write the answers now, so if you want to, pause the video, whatever you want to do as far as stopping it or pausing it. When I do this problem, I end up with the big matrix to be 1, 2. Now, I'm using a capital X here, though I don't think it translates very well. So X is 1, Y is 2, because they actually broke down the entries in this one. You also might see it written as an ordered pair, 1, 2, because it's an X and a Y. So any of these would be fine for displaying your answer. My answer for number 2, if I do this, remember A, B, A inverse B, it should be 2, 9, 5, 3. And finally, the third one here, if you do this one correctly, this is going to be A. B is going to be this guy minus that guy. You should end up with, I made a fun matrix here, 1, 2, 3, 4. Happy solving. See you next video.